Let's solve some linear regression problems. We have a question which says for a bivariate data, x bar is 53. X bar is nothing but the average value of x. So what I have here is the average value of x, which is 53. Uh, y bar is 28. So again, the average value of y is 28. B by x. So b by x is nothing but the regression coefficient of y on x. That's negative 1.2. And bxy, the regression coefficient of x on y is negative 0.3, and we are asked to find a bunch of things. First one is the correlation coefficient between x and y. So that is nothing but the coefficient r, and by definition it is the geometric mean of these two regression coefficients along with their sign. So if both of them are negative, I'll have a negative sign, and this quantity is the geometric mean of 1.2 and 0.3. You can calculate that it comes out to be 0.6. Obviously, because both of these are negative, I'll put a negative sign up front. So that's the correlation coefficient, negative 0.6. We need to estimate y for x is equals to 50. Now to estimate y for a given x, I need the regression equation of y on x. And I have the regression coefficient of y on x. What I don't have is the constant a. But we are given the average value of x and y. So using average value of x and y along with this b, I can calculate the constant a. And you can check that it comes out to be 91.6. Similarly, for the next question as well, I can calculate the constant for the regression equation of x on y. You can check that it comes out to be 61.4. You'll need to use the average values of x and y along with this regression coefficient, because this is the regression coefficient of x on y. You can check that it comes out to be 61.4. And once we have that, the first regression equation of y on x is nothing but this a value plus this b value times x, and the regression equation of x on y is nothing but this a value plus this b value times y. So yes, if we are given x is equals to 50, you can see that using the regression coefficients of y on x and this constant, for a sample x of 50, the value of y comes out to be 31.6. And for the other one, if you are given the value of y, sample value of 25, you can check that using the other regression equation, that's basically 61.4 minus 0.3y. If you put a 25 as y value in that, you'll get the predicted x value as 53.9. So that's the equation. That's the answer for the third question. So I can even mark the answers. I can say this is the first answer. Hold on. Let's see. This is the first answer. This is the second one, and this is the third one. So these are the answers that you get for 3 questions. Next question. From the data of 20 pairs of observations on x and y, following results are obtained. X bar is 199. So again, we have 20 data points. So our n is 20 and x bar is 199. So average value of x is 199. Y bar is 94. So we have the average value of y as 94. And now here we are given the sum of not the original x values, but the x values are shifted, and they are shifted by the average itself. So what we have is the sum of x squared, which are shifted by the average. And yeah, we have the sum of the x squared values as 1200. Remember that these are shifted. The sum of y value squared is 300, and the sum of the product values again shifted. They are negative 250. So yes, these are the important thing to notice is that these are shifted values, shifted specifically by the average. And yeah, we are asked to again find a bunch of things. The very first thing is linear regression of the line of regression of y on x, and a lot of other things. But the very first thing that we can calculate from this is that we are given the sum. And we know that there are 20 quantities, so we can find the average by dividing each and every sum by 20. So we get these average values. And again, remember that these are again shifted values. They are not the original average of the x squared. These are shifted as well. And since these are shifted, I can calculate the variance as just the average of x squared, because remember what variance was. Variance was the average of the square values minus square of the averages. But since here now I'm shifting, my new average will become 0. So I need not subtract anything. So what I can say is this variance is nothing but the average of the x squared, that is 60 itself. That's why I have just 60 over here, which is the same value as average of x squared. And similarly, I can say that variance of y is nothing but the average of the y squared, because these are shifted by the average itself. And therefore, I get the variance of y as 15. And similarly, the covariance is nothing but the average of the product values. I don't need to subtract anything, because whatever I need to subtract, that is 0 currently. And yeah, you can see that as sums are shifted by the average, these are just found by the averages itself. I don't need to subtract anything. That's the emphasis. And yeah, now that we have all the variance and covariances, we are in a position to find the regression coefficients and the constants. This is the same drill that we did in the last video. This is nothing but the covariance divided by the variance of x. So you can see that this is nothing but negative 12.5 divided by 60. You can check the number that it comes out to be negative 0.2 something. And similarly, the regression coefficient of x on y is nothing but the covariance of xy divided by the variance of y, because remember here y is the variable. So we need to divide by the variance of y. And once we have the regression coefficients, again same drill, we can calculate the constants a, and yes, let's see. Yes, these are calculated using the average values, of course, and the regression coefficient. And once we have these constants, these regression coefficients, we can say that the regression line is nothing but a, that is 135 point something, plus b times x. So b is negative 2 point something here. So it is negative 0.21 somethings into x. And the other regression line is x is equals to this a, 277 point somethings, plus this b, that is negative 0.83 somethings into y. So these are kind of the answer to the first two questions. And the third question is asking for the correlation coefficient, basically the R value. Again, by definition, it is the geometric mean of the regression coefficients along with their sign. So if you calculate the geometric mean of these two quantities, it will come out to be 0.41 somethings. And since them both of them are negative, we put a negative outside. So that's the answer for the correlation coefficient. Next question. From the data of 7 pairs of observations on x and y, following results are obtained. So yeah, we have n is equals to 7 here. Now, and we are given the information of the sum of the x values shifted by 70. Now remember, 70 may or may not be the average of the original x value. So here in the earlier case, we were shifting by the average itself. This was average x. But here it may not be the case. So this 70 is just a shift in the x value. And similarly, this 60 is just the shift in the y value. We don't know what the average is. So what you can actually consider this as if I recall the previous exercise, in the previous video we did, we shifted the origin to get UV values from the XY values. So you can see that this XI minus 70, or basically X minus 70, you can consider this as U, and this Y minus 60, you can consider this as V. So what you are given is the sum of the U values. So I can say it is the sum of, I should have actually written sum of U values, but I think it makes sense just to call it sum of X. It's negative 35, but in behind the scenes, this is actually the sum of the U values, and this is the sum of the V values. It's negative 7, because here the sum of the Y minus 60 is negative 7. Similarly, here you can see that the sum of the x minus 70 squared values, which is nothing but u square values for us. So it is the sum of the u square values. Again, behind the scenes, this is the sum of the u square values, not the x square values. I actually should have written u square, but never mind. This is the value 2989. Sum of the, again, this is nothing but v square. So I should say this is sum of v square values, 476, and some of the product values, because this is u and this is v, this is the product of u and v. So sum of the product values, sum of uv should be 1064. And once we have the sum values, it's easy to calculate the average value. So you just divide all the sums by your number of quantities, that is 7 quantities, to get the average values. And once you have that, you can calculate the variance of both the quantities. Again, this should have been variance of u. Behind the scenes, this is actually variance of u, because this is not average of x, this is actually average of u. So variance is nothing but Okay, let's see. It is nothing but the average of the square values minus square of the average values. So it's 427 minus negative 5 squared. So you can see that it's 427 minus 25, which comes out to be 402 definitely. And again, this variance of y, it is actually behind the scenes, this is variance of v, but we call it, again, it's calculated using the average of the square value 68 minus square of the averages, and square of the average is nothing but negative 1 squared, so it's just 1. So 68 minus 1 gives you a 67, and covariance is nothing but the average of the product minus the product of the averages. So it is 152 minus the product of these two quantities, that is 5. So 152 minus 5 gives you 147. And once you have these variance and covariances, you can calculate the regression coefficients. Again, remember these behind the scenes, these are the regression coefficients of v on u and u on v respectively. So again, these are calculated using the variance and covariances. And once you have that, you can find the constants, a constant, which are actually the constants of u and v. I should have actually written u and v over here, but okay, it's understood that it is regarding u and v. Using the regression coefficients and the average values. These are the average values that we calculated. So we get the constants a for both the equations, of course. And now comes the interesting part, because behind the scenes these were not x and y, these were u and v. So my ideal equation would be, if I were to write it here, my ideal equation would be, first I'll talk about the equation, the linear regression equation of v on u. So it will be v is equals to this a value, let's say 0.83, let's say 0.83 plus this b value 0. Let's say 36, 0.36 times u. And since we shifted because remember where we got these u and v's from, these were nothing but my original x values shifted by 70 and original y value shifted by 60. So for u is nothing but the shifted value. So if I were to have the original values, I would put I would put an x, I would put an x plus 70 here. And similarly, oops, instead of a v, I would put a y plus the shift in y, that is 60. These are the, this is the actual regression equation, and that's what we have here. And once you simplify it, you get the final regression equation as y is equals to 0.3x minus 34. And very in parallel lines, and similarly you can calculate the regression equation of the x on y. It comes out to be x is equals to 2.19y plus 58.59. So yeah, that's all about the first and the second question. And the third question is just the correlation coefficient. It is nothing but the value of r, and we know it is nothing but the geometric mean of these two quantities along with their sign. So since both of them are positive, I've taken a positive, and you can calculate that the geometric mean comes out to be 0.89 something. So yeah, this is the final answer for this question. Next. You are given the following information about advertising expenditure and sales. So we have advertisement expenditure in rupees in lakhs represented by X value, and sales in rupees in lakhs represented by values, Y values. And we are given the arithmetic mean of the X value. So we have the average of the X, which is 10, average of the Y, which is 90. And we are given the standard deviation of both X and Y. So we are given standard deviation of X as 3 and standard deviation of Y as 12. And we are also given the correlation coefficient between x and y, which is 0.8. So r is equals to 0.8. And we are asked to again obtain the two linear regression equations and find a bunch of quantities. So the very first thing that comes to my mind is using this standard deviation, I can actually calculate the variance, because recall what standard deviation is. Standard deviation is nothing but the square root of the variance. So if I were to calculate the variance, it would be nothing but the square of the standard deviation. So if I have a standard deviation of 3, the variance will be 9. And if I have a standard deviation of 12, my variance will be 12 squared, which is 144. So this is the variance of the x values. This is the variance of the y values. And again recall that this R, there's another alternate formula for R. It is nothing but the covariance, rather, okay, let's see. Okay, yeah. Yes, okay. This R, the correlation coefficient, there's an alternate formula for this. It is nothing but the covariance of xy and divided by the product of the two standard deviations. So it is nothing but, if you were to find the covariance, you would have the product of both the standard deviations along with the correlation coefficient, and you can calculate that it comes out to be 28.8. But once we have the covariance and the variance of the two quantities, we are in a position to find all the regression coefficients. It's the same drill that we've been doing in the past video as well. So this regression coefficient is nothing but the covariance divided by the respective variance, and you can calculate this a constant a using the b values and the average values. You can check that the values come out to be these. So we are in a position to actually answer the first question. The two regression equations are nothing but the first one is y on x, so it is y is equals to 58 plus 3.2x, and the second one is x on y, so it is x is equals to negative 8 plus 0.2y. So yes, this is these are the two regression equations. And the second question is asking what is the likely sales when the advertising budget is rupees 15 lakh. So the advertising budget is given by X value. So we are given X, a sample value of X as a 15. So we have a sample of 15 and we are asked to uh, find the likely sales. So we are asked to estimate or predict the Y value. So we are asked to predict the Y value. If I were to, yeah, these are the Y value. This is the Y value that using the first equation, because here in the first one, y is a function of x. Since we are given x, we can predict y from this. It comes out to be 106. For the second one, what should be the advertising budget if the company wants to attain annual sales target of rupees 120 lakh? So 120 lakh is the sales, so it is the y value that we are given. So we have a sample y of 120, and we need to predict what the advertising budget should be. So we need to predict the x value. So for that, we can use the second equation, that is negative 8 plus 0.2y. So if you plug in 120 that 120 in that, you can see that the predicted x value comes out to be 16. So yeah, just as a final reminder, this answers are in these answers are should be in lakhs of rupees because the units were rupees in lakh. So here the answer is rupees 106 lakh, and here the answer is rupees 16 lakh. Next question. Bring out inconsistency, if any, in the following. So yeah, these will bring out inconsistencies using the properties of the regression coefficients that we know, which connect with the correlation coefficient R. So what we are given is that the sum of the regression coefficients is 1.3 and the correlation coefficient R is 0.75. So what we have is that the absolute value is a 1.3. Of course, it's positive, so its absolute value is the same thing. And from that we can calculate the average of these two, because its average is nothing but the value divided by 2, because these are two quantities. So what we find that the average value is 0.65. And we know from the AMGM inequality that the arithmetic mean, that is this value, should be greater than or equal to the geometric mean. Now, R was the geometric mean, and precisely mod R was the geometric mean. So the geometric mean is 0.75, but the arithmetic mean is 0.65. So that's the inconsistency here. Arithmetic mean cannot be less than the geometric mean. It always has to be greater than geometric mean. So this is inconsistent because this arithmetic mean is not greater than or equal to the geometric mean. That's the inconsistency here. For the second one, we have both the regression coefficients to be 1.5. That's very inconsistent, first of all, but let's go with the problem. We are also given the value of R, which is negative 0.9. One thing that is very inconsistent here is that both regression coefficients are more than 1, which is very invalid. You cannot have both of them to be more than 1. That's one condition that the regression coefficients should satisfy. They cannot be both more than 1. So that is one inconsistency. But even if you consider these as a regression coefficients and you calculate R, it won't come out to be negative 0.9. So what we have actually done is the product of bxy and byx, the product of the two regression coefficients. You can see that the product of 1.5 and 1.5 is 2.25. but it should be equal to r square. But if you calculate r square from this, it comes out to be 0.81, and these two quantities don't match because this is 2.25 and this is 0.81, and we know this should all these quantities should match. So that is also another inconsistency here. So one inconsistency is because one of them is greater than one and the other is less than one. So that is that it cannot happen. And the other inconsistency is that these two are not matching. Next, I think another inconsistency here would be that since both of the regression coefficients are positive, the correlation coefficient should also be positive. So it's kind of another inconsistency. So there are in fact three inconsistencies here, but yeah, this is the answer. Next one is the regression coefficient of y on x is 1.9 and the regression coefficient of x on y is negative 0.25. And yeah, very clear inconsistency that both of them are not of the same sign. One of them is positive and the other one is negative. This is not possible. They should be either both positive or both negative. So that is the inconsistency here. The last one is the regression. One of the regression coefficients is 2.6 and the other is 1 upon 2.6. And if you look carefully, both of them are positive. So yes, that is consistent. And we are not given the value of r. So there's nothing inconsistent about it. And also you realize that not both of them are more than one. Obviously this is more than one, but on the other hand, this is less than one. So that is consistent. So we cannot see any inconsistency here. So this is in fact consistent. So I would say this is consistent. There's no inconsistency here. This is consistent. All the previous three were inconsistent, and these were the reasons behind them. Next question. Two samples from bivariate populations have 15 observations each. So we have n is equals to 15. The sample means of x and y are 25 and 18 respectively. So we have average values of x and y, 25 and 18. The corresponding sum of squares of deviations from respective means are 136 and 150. So what this is telling you is sum of the square values, but they are shifted by the mean. So they are shifted by the averages. So these sum of the x square values, 136 and 150, these are basically shifted by the average value. Also the sum of product of deviations from respective means is 123. So again, the sum of the product is 123, but remember that it is shifted by the average values. We need to find the equation of line of regression of x on y. So yeah, all of these quantities are given. We need to find the regression equation of x and y. So one thing is very clear, that if we are given the sum, we can calculate the average. Just divide the sum by 15 to get the average values. You can check that these are the averages. And once we have averages, you can directly use them as the variance and covariance, because remember these values were shifted by the average itself. So there's no need to subtract anything from this, because if you are shifting everything by the average, the new average will become 0. So it's as good as subtracting 0. So it's just you can use the average of the x squared values as the variance of x, average of the y square values as the variance of y, and average of the product values as the covariance between x and y. You don't need to subtract anything from this. So yeah, and of course, once you have the variance and the covariance, you can calculate the regression coefficient, and with the average and the regression coefficients, you can calculate the constant. So these are the regression equation of y on x and x on y. And mind you, the question only asked for x on y. So this is kind of we have done it for both the equations, but never mind. The answer for this question is just the first one. We only needed the regression of x on y. So this is the regression equation. Next question. For certain bivariate data, the mean values of x and y are given to be 25 and 20. So we have the average values of x and y. And the standard deviations are given to be 4 and 3. So standard deviations are 4 and 3. We are also given that r is equals to 0.5. So this is kind of a moderate relation between x and y. It's neither weak nor strong. This is one of the examples. We are asked to estimate y when x is 10 and estimate x when y is 16. So we will be able to estimate this once we have both the regression equations. And yeah, the way to go forward is once you have the standard deviations, you can just square them to get the variance, because remember variance is nothing but standard deviation square. So if standard deviation is 4, the variance will be 16, and the standard deviation is 3, the variance would be 9. The covariance can be found out using the product of these three values, because remember, we don't have the any other information of average of the squares or average of the products and all of that information. So we cannot find this covariance using average of the products. Instead, what we can do is we can find the product of these three quantities, because remember, this is the alternate formula for the covariance. It is nothing but the correlation coefficient R multiplied by the product of the standard deviations. So if you multiply 4, 3 and 0.5, the value that you get is 6. So that's the covariance. And once we have covariance and covariance, you can go ahead and do the same drill to find the regression coefficients of both the equations and the constants for both the equations using the averages, of course, and the regression coefficients. And once you have the line of regression, you can have a line of regression x on y is this, and so you can plug in or rather y on x as this, and you can plug in the value of x as 10 to get a predicted y value of 14.375. So that's the kind of the answer for the first part. So when x is 10, we can predict that y is 14.375 something. And similarly, if I were to scroll down from the regression equation of x on y, if you have a sample value of x, y as a 16, you can use the equation to predict y as a 22.33 something. So when y is 16, x value is 22.33. That's the answer. These two are the answers. Next question. Given the following information about the production and demand of a commodity, obtain the two regression lines. So yeah, production is denoted by X, demand is denoted by Y. We are given the mean and standard deviations, and we are also given the coefficient of correlation between X and Y, that is 0.6. So we are given the R value, that is kind of the most important value here. So yes, that's what we have, the average values, the standard deviations, and the R values. And very similar to the previous question, we can find the variance from the standard deviations, just the square of the standard deviation, and we can find the covariance using the product of R and the standard deviations. So that's the covariance. And once we have variance and covariance, it's very easy to calculate the regression coefficients and the constants to get the line of regression or both the lines of regression. And we are also asked to estimate the production when demand is 100. So remember, demand is given by Y. So when Y is 100, we are asked to estimate X. So we have a sample value of Y. So we can use the regression equation of X on Y to predict what X will be. So if I see clearly here, for a sample value of Y is equals to 100, I can predict that X is equals to 90 from this equation. That's your answer. Feel free to check the numbers anytime. Just pause the video, check the numbers and come back. Next question. Given the following data, obtain linear regression estimate for X for Y is equals to 10. So since Y is given, Y is a sample value and we need to predict X. This is the case of finding the line of regression of X on Y. And we are given a bunch of data. Again, it is just different notation. It is very similar to the previous problem. In fact, we were given the mean values and the standard deviations. So here we are given the mean values of X and Y. These bars represent the mean. And this sigma notation is nothing but another notation for standard deviation. So this is nothing but the standard deviation of X, which is 3.2. And standard deviation of Y is 16. So we have the average values, the standard deviations, and we are also given the correlation coefficient, which is 0.7. R is equals to 0.7. Again, very same drill. We can find the variances from the standard deviations, the covariance from R and the standard deviations, and we can find the lines of regression. And remember, we need to find X when Y is given. So we are only interested in, I think, the first part. The second equation was not required, but I have done it just for this completion sake. So you can check that the regression equation of X on Y comes out to be negative 11.8 plus 3.5, negative 11.8 plus 3.5x. Or we needed the second one. I'm so sorry. Okay, since we wanted X on Y, we needed this equation. We need X in terms of Y. So you can check that you can get the x is equals to 5.5 something so plus 0.14y. And when you plug in y is equals to 10 in that, you can predict that the x value comes out to be 6.9. Feel free to check the numbers. And of course, we needed only x on y. The first one was done just for completion's sake. Next question. An inquiry of 50 families to study the relationship between expenditure of accommodation, rupees X, and expenditure on food and entertainment, rupees Y, give the following results. So we have the sum of the X values. So yeah, even before that, we have 50 families. So N is equals to 50, obviously. And the sum of the X values is 8,500. Sum of the Y values is 9,600. Again, this is notation for the standard deviation of X. So we have standard deviation of X is 60. Standard deviation of Y is 20. And we are given the correlation coefficient as 0.6. We are asked to estimate the expenditure on food and entertainment. So we are asked to estimate what is food and entertainment. Food and entertainment is represented by Y. So we are asked to estimate Y when expenditure on accommodation is 200 and accommodation is represented by X value. So when we are asked to actually estimate Y when X is 200. So we need the regression of Y on X. So, and again, to find that equation, you can go through the same drill. You can find the average values. Because remember, we are given the sum. We can just divide it by the 50, n is equals to 50 to get the average values. And the variance and covariance can be found out using the same drill. The regression coefficients and the constants, same drill. We have the linear regression equations as these. Out of this, I think we need the first one because we need the regression of y on x because this 200 was the x value, accommodation x, yes. So we are given the x value as 200 and we need to predict y, and using the first equation you can see that the predicted y value comes out to be 198. So you can answer to the second question is the estimate on expenditure on food and entertainment is rupees 198. So that's kind of the answer. And of course, we needed only y on x. The second one was done just for completion's sake. Next question. The following data about the sales and advertisement expenditure of our firms is given below in rupees crore. So we are given the mean of the sales, the standard deviation of the sales, and we are asked to estimate the likely sales for a proposed advertisement expenditure of rupees 10 crore. And there's another question. And yeah, since they have not mentioned what x and y is, I have denoted it. I have defined it myself. Let x denote the sales value and y denote the advertisement expenditure in rupees crores, of course. And so the average of the x values is 40. Average of the y values is 6. The standard deviations is 10 and 1.5 of x and y respectively. And one thing you can calculate from this is that the variance is these values is nothing but the square of the standard deviations. And that's it, I think. There's nothing more that you can calculate from this information. This question is a bit, I think, ambiguous because we are not given any other information. We are not given the covariance. We are not given the correlation coefficient, that is R. So it's actually, I don't think it's possible to find anything else, let alone the line of regression, let alone prediction of any value. So I don't think there's any way to solve this problem just with the information that we are given. So yeah, that's it. As neither correlation coefficient R nor the covariance is given, this regression equation, the regression equations can't be found actually. So this problem is actually not solvable. So I believe there is the information is missing. Some information is missing. So if yeah, if anyone can point it out, I'll be glad to know. So yeah, just for this question, we cannot solve this question with the information that they have given. Next question. For a certain bivariate data, the following information are available. They're given x and y values. The arithmetic mean is 13 and 17. So the arithmetic mean is 13 and 17 average values. The standard deviation is 3 and 2. Again, same drill. And here we are given the correlation coefficient, that is 0.6. So R is 0.6. And we are asked to estimate x when y is something, and we are asked to estimate y when x is something. So this is the case when we need the line of regression of both y on x as well as x on y. And using the same drill, you can find all of the quantities and the lines of regression, and using the lines of regression, the sample values for y is equals to 15, you get the predicted x value is 11.2 using the first equation, and for a sample value of x is equals to 10, you can predict using the second equation that the predicted y value comes out to be 15.8. So if I were to mark this, this is the first answer and this is the second answer. Feel free to check the numbers, but yeah, we are done with the problems.